Welcome class 8 to the second class of 2021. In the first class of chemistry, we discussed matter, the kinetic theory of matter. Now today we will continue with the same chapter matter, but we will discuss a very short class indeed. We had last class, so today also we will talk about matter, but change of state of matter. But we will discuss about the molecular structure of matter in the solid, liquid and gas. Okay. So, you know the three states of matter, isn't it? The three states of matter are solid, liquid and gas. So, it can be changed from one state of matter to another by providing heat or by cooling it, isn't it? Like ice can be turned into liquid, water, or water can be turned into ice. The liquid can be turned into solid, or liquid can be turned into gas, or gas can be condensed back into liquid. So there is a change of state of matter all around us. So the change of state of matter depends upon the property of the state of matter depends upon why are there the existence of three states of matter, solid, liquid and gas. Why? Because of the intermolecular force of attraction and intermolecular space. So over here also the change of state of matter depends on the intermolecular space, number two, intermolecular force of attraction and the collision between the molecules. So molecules will collide when the molecules are given heat. The kinetic energy of the molecules increases and they will collide with each other. So today we are going to discuss the molecular arrangement of solid, liquid and gas. Or in other words, we will discuss the properties of solid, liquids and gas according to its intermolecular structure or the molecular nature. Okay, molecular nature of matter. Like solids, the molecules over here, the molecules are very close. The molecules are very, very close to each other in solids. In solid, the molecules are very, very close to each other, as you can see here. Why are the molecules very, very close to each other? Because the force of attraction or the intermolecular force of attraction between the solid is very, very strong. So therefore, they are pulled together. All the molecules are pulled together and they have very less intermolecular space. They have very less intermolecular space, and due to which, if they are provided with energy, if they are provided with given energy, they will vibrate. They cannot move around, so they vibrate in its mean position. They just vibrate in its mean position. So the intermolecular force of attraction in the solids is very, very strong. It is in fact the strongest. So the intermolecular space between the molecules in solids is practically absent. That is very less intermolecular space, and the molecules are very, very closely packed together. Therefore, the molecules in solids, they hardly move about. They just vibrate in its mean position. And in case of solids, the physical nature of the solids, as we say, they have definite shape and they have definite volume. Now, why do solids have definite shape and definite volume? Because the molecules, the force of attraction between the molecules is very strong and the intermolecular space is minimum, almost negligible. So therefore, they have a definite shape and definite volume, and they do not flow. They do not flow. With the same reason, they do not flow. And they are hard and rigid. So these are the properties of solid. Now we come to the liquid. We come to the liquids. Liquids are further apart. Is it okay? They are not very close to each other. And that is the reason, as you can see the molecules here, they are not very close to each other. They have intermolecular space between them. As you can see. So therefore, the intermolecular force of attraction is weak. The intermolecular force of attraction in the liquids, it is weak. And why is it weak? Because they are further away from each other. They are further away from each other because the force of attraction between the molecules is weak. Therefore, they are not rigid. The molecules, if they are provided with energy, if they absorb energy, what happens? They move, the molecules will move around within the liquid. They move around, the molecules usually, they move around within the liquid. Is it okay? So, again, the molecular arrangement, I want to repeat it. The molecules are further away. That means they have intermolecular space. And the force of attraction between them, the intermolecular force of attraction between the molecules is weak. And if provided with energy, they move around. The molecules move around within the liquid. Now we come to the physical properties. Liquids do not have definite shape, but they have definite volume. Liquids have definite shape. They have definite volume, but they do not have definite shape. And they can flow from higher level to lower level, and they are not rigid. They take the shape of the container. Okay. Now we come to the gases. We come to the gas, the properties of gas. The molecules are further away from each other. The molecules are further away from each other. Look at the intermolecular space between them. The intermolecular space, they have a very large intermolecular space as compared to the liquids. They have very large intermolecular space. Okay, the molecules have very large intermolecular space, and the force of attraction between them is also very, very weak. And that is the reason why gases, they move randomly. They move randomly anywhere they want to. Why? Because the force of attraction is almost negligible, and they are very large intermolecular space. That's why they move around everywhere. And if we to talk about the molecule, that was about the molecular nature. Now if we talk about the physical nature, now gases, they do not have definite shape, nor do they have definite volume. That is the reason why they don't have definite shape and definite volume. Why? Because the intermolecular force of attraction is very weak, and they have very large intermolecular space. So that is the reason why they do not have definite shape, they do not have definite volume, gases. So the intermolecular force of attraction is very weak, isn't it? So therefore, they are not rigid. They are not rigid, and the molecules move around anywhere it wants to, unlike solids. So if provided energy to the molecules of the solid, they just vibrate in its mean position, but the molecules of the gases, they move around anywhere it wants to. So the intermolecular force of attraction in the gases is the weakest. So the intermolecular space in the gases is largest in comparison to liquids and solids. As a result, the molecules in the gases are very far apart, and they move randomly, and they occupy the entire space available to them. And the molecules in gases also frequently collide with each other. The molecules in liquids and the gases, but gases, they frequently collide with each other. And the molecules also frequently collide with each other and also with the sides of the container, thus creating pressure. Okay, so the more the number of molecules collide with the walls of the container, the more will be the pressure. We will talk about that later in the next class. So in the next class, we are going to, this was the intermolecular, the property of solid, liquid and gas according to its molecular nature. So in the next class, we will try to understand why does the change of state occur? Why is there change of state? Liquid, what happens when liquid changes into gases, or gases condenses back into liquid, or solid melts, and what happens when solids melt and liquids freeze, and so on. So why does change occur? State of change occur? We will discuss it in the next class. So for that, you have to understand whatever we have dealt today. So I hope you understood the lesson today, So thank you so much.